So let's begin the 6.5 notes on fossil fuels. So let's start the slideshow. All right. So the process of fossil fuel formation is, we've talked about it several times. So I'm going to go into a few details with the various types of fossil fuels. And before we get started with this, I should probably even like define what a fossil fuel is, although I feel like you probably know this from your, junior high and maybe even elementary years. But a fossil fuel is basically a non renewable energy resource that's formed from the decomposed remains of ancient plants and animals that were buried underground, hundreds of millions of years ago. And so if we look at this image, you can see the formation of fossil fuels taking place here underneath these rock layers. Over here, underneath oceans or areas that used to be oceans, we'll find oil. We find natural gas. Again, some natural gas over here. And so these can be extracted, which this is showing you that here. And then we can use that for combustion to generate electricity in the forms of, we can also generate heat, or we can generate power from those things. Okay. And so when we're talking about generating heat and power, we use a term with fossil fuel combustion that we call cogeneration. And that occurs when a fuel source is used to generate both useful heat and useful electricity. Not all heat is useful, but in terms of cogeneration, it is. And so sometimes if we can turn that heat into something useful, we will, you know, use it. And then if we're also generating electricity, that's where we get that term cogeneration. So if you see the term cogeneration anywhere, that's what it actually is referring to. All right, so fossil fuel combustion. So fossil fuels are combustion occurs when we mix oxygen with those hydrocarbons. Now, when I say fossil fuel, I want you to just think hydrocarbon. And so this is what a hydrocarbon is. If we look at this molecule over here, it's a long string of carbons. That's where the name carbon comes from. And then hydro refers to all of these hydrogen atoms that are attached to those open bonds on those covalent bonds of the carbon. Okay, so we have these long stretches of molecules, long carbon molecules that have just a bunch of hydrogens on them. And that's essentially all that fossil fuels are. And so that's why we call those hydrocarbons. So hydrocarbon, think fossil fuel, think of this picture. All right, and then that releases when we mix that with oxygen, we release a lot of energy as heat, and it produces CO2 and water. And let me click here to show you this process right here. Here's the combustion of a fossil fuel. You mix whatever the fuel is. In this case, it's methane, which is natural gas. But this could be a long hydrocarbon strand like we see up here. We mix it with oxygen. We end up producing a lot of energy, water, and carbon dioxide. That carbon dioxide, that's the problem when it gets into the atmosphere in excess amounts. Okay. So remember that combustion is just a step in the carbon cycle. This is why because we're burning those hydrocarbons and we're releasing not only the energy that we want, but we're also releasing all of that carbon that's stored in these molecules, which you can see is quite a bit. And that reacts with the oxygen in the air to form carbon dioxide, which is the problem that we end up with. And then methane is just natural gas. That's an example of a fossil fuel. Gasoline, propane, butane. These are maybe words I haven't mentioned before. And then coal. These are all hydrocarbons, and they all release energy in the exact same way. Wood and biomass also work the same. It's basically us just burning that carbon, and then it reacts with the oxygen in the air to form that carbon dioxide and give off energy. Okay, so this picture is really important, and it's very important that you understand um, these steps. And so I'm going to explain this to you, and then this will be the same process for like every type of natural resource that we're combusting to generate or that we're using to generate electricity. So, the number one source of electricity production globally is coal. That's followed second by natural gas and third by oil or petroleum products. And so basically, these steps are what's involved in the energy production. So let's take a look at the picture before you write this down so that you understand this. So the first thing that we have here is the fuel. In this case, we're going to talk about coal since it's our number one source. And we pump it into this furnace essentially, and we burn it. And when we burn it, at the top of this furnace or throughout this furnace, there's these water pipes that are pumping in water to heat up the water and produce steam. So the steam is produced. The steam actually will be pushed into, be collected from the burner and pushed into a nearby turbine. A turbine is essentially a fan that when air is pushed over it, it just operates as a fan and it's going to spin. It's a really large fan, though, not like a fan in your house. It's very large. And so this turbine spins. And then within the turbine, there's something called a generator, which is essentially just an electromagnet. So as it's spinning, it's generating electrons, which are going to flow and move into this transformer that will then collect that energy, collect that electrons that are flowing, and pump it into our electrical grid. And so the process that and you don't need to understand how that works necessarily. If you're interested, you could look up a video on that. But essentially, you need to know we've got a fuel, it is going to be burned. The heat from burning that fuel is going to heat up water to generate the steam. The steam turns that big fan turbine called a turbine. You need to know that word. The turbine is connected to an electromagnet generator, which generates electrons, which are going to flow. When we get electrons flowing, that's where we get electricity. That electricity is going to be collected in transformers that transform the electrons into electrical energy and then pump those out into our electrical grid. Okay, so that's what you really need to know. Now, another thing that you need to know, because it's going to give us some information about how beneficial for the environment fossil fuel generation or fossil fuel combustion um, is that we've got all of this hot water now as a result of heating it up when we burn the fossil fuel. So what do we do with it? Well, the hot water moves into these large smokestacks that then cool off the water, and then they can release the warm water, not boiling anymore, but warm water back into a reservoir. And so that's what we see when we're near an electrical power plant. We might see some like dark smoke being released, especially if it's a coal power plant, but we'll also see a lot of white smoke that's coming out of these large white smokestacks. And these are the cooling towers. And so, really, all that's coming out of this white cooling tower is steam. Now, that does, create it's just water, it's just hot water. So, it does create a little bit of thermal pollution. But the smokestack itself, this big white one, is not creating a lot of pollution. This smokestack that has a lot of dark gray or black smoke coming out, that's definitely a lot of pollution. This one, not so much. The problem with this one is that we're dumping some of this warm water back into the river, which can create thermal pollution in rivers, and then that can be a problem for the aquatic life. That is one of the issues with burning, our electricity production that we use currently. Okay. So it's important to note these steps that we went through. You need to write this down in your notes and make sure that you have this memorized. The last 4 years, the FRQs on the AP test has involved something from fossil fuel combustion, somewhere, whether it was a calculation, whether it was an environmental issue and solution, whether it was the scientific method, somewhere in the FRQs, fossil fuel combustion has been a topic for the last 4 years. So, I mean, it could happen again. They like to talk about fossil fuel combustion. It's a real environmental problem that we need to address in throughout the world, actually. Um, but you need to understand these steps. And so these steps occur with coal when we use it as a fuel, when we use oil as a fuel, when we use natural gas as a fuel, when we use biomass, when we use trash. All of these work in exactly the same way. Even nuclear energy works the same way. We use nuclear fuel rods, uranium rods, to basically so much electricity is released from that rod that it heats water. So we don't have to burn it. That's why nuclear energy is a lot cleaner in terms of air pollution than fossil fuel combustion. But nuclear energy basically works the same way, producing that heat. Okay. All right, so that's it for that slide. So, what are the environmental consequences for coal specifically? First of all, there's a lot of habitat destruction that goes into clearing the land for mining. It also produces a lot of pollutants. We saw a chart earlier that compared it to oil and natural gas, and it releases a lot of CO2 into the atmosphere. So, a lot of greenhouse gases are going into the atmosphere. It also releases a lot of particulate matter in the forms of soot and ash. This irritates the respiratory tracts of both humans and animals. And we've seen the increases I've mentioned before in the rates of lung cancer in areas where we burn a lot of coal. Okay, so that's a problem. It also produces toxic ash. I mentioned that there were these ash pits that, if we looked at this last picture, let's see if we can get back there really quickly. Not letting me. Let me go back to the previous slide. Oh Lord, I got to do all this. Okay. But as a result, we burn the coal and there's all this ash left over. And so what do we do with it? Or if you have a wood fireplace, you know there's a lot of ash. We have to do something with the ash. And so in Indiana especially, but across the globe, we have these ash disposal ponds that are very toxic. They have high levels of waste, hazardous waste, which is toxic for the environment. So that's a real problem with coal. And let me get back down to where we were. And so this toxic ash is contaminated with lead, with mercury, with arsenic, very bad for humans and wildlife. And they're taken to either landfills or they're stored like we do in Indiana in ash ponds. These areas will actually leak into the ground and can contaminate our surface waters, or it can go into the soil and impact the plants and the things that are growing there as well. So it's a real problem. And let me get rid of my picture for a second so you can see what happens with these coal ash ponds that we end up with. You can imagine it rains, and now that rain all has to infiltrate the pond and go somewhere. So it impacts the shallow groundwater and impacts deep groundwater. It can impact, the local rivers and things. The other issue with coal is that it releases SOxes and NOxes. We're going to talk about why those are so dangerous when we get to Unit 7, but this actually creates respiratory issues as well. It contributes to smog, to acid precipitation. Again, it could be another reason that we're having issues with, lung cancer in areas where we burn coal. And so that's all a problem. A pro, it does generate electricity. So this is a positive for using coal. It is only about 30% efficient as a fuel source. And because we are releasing, so when we burn the coal, you can imagine we're using energy. And then, so that kind of decreases from the 100% amount of energy we would get from the coal. And so we have to burn it. And so that's going to cut down on its efficiency. And then, how much energy can we actually harness? How much power can we harness from that coal? It's only about 30%. And so natural gas is much more efficient when we burn it. We can actually collect 60% of the energy that is, available in that natural gas. But most of the energy is going to be lost as heat. Okay. And so, um, we can combine or have these combined heat and power systems where we're collecting all of the heat to help heat up that water. And they're about 90% efficient. Um, and so that is actually a really good thing. It's much better than just coal and natural gas alone. Collecting the energy or the power from them, if we actually collect that heat as well, that's a real benefit. It improves that 30, especially that 60% efficiency. It improves it to about 90%. Coal, I don't think, is as well with its cogeneration combined heat and power source. Okay, so there we go. All right. So oil and petroleum extraction, how do we get it? Well, we extract it, like we said, with either we've seen these oil rigs, we maybe have seen these oil pumps. And then let me get rid of my picture. You can see again, we've talked about this already, but the tar sand pits where we have to pump steam into the ground. The problem with the tar sand pits is this bitumen is not liquid, so we have to turn it into liquid. That's why we use the steam. It heats it up, it turns it into a liquid. We can then pump it out of the ground. This requires lots of water. They tend to use, there's a lot of tar sand pits areas in parts of the United States where there's water issues. And so using a lot of water is a problem already. And so now we're going to use a lot of water for extracting a natural resource. You have to look at the cost and the benefits, and you really have to do analyses to see if that's going to be beneficial for your area. But that is a problem with oil and uh, especially that tar sand, um, getting the oil out of the tar sand. So, what are some consequences for tar sands? Primarily, we have habitat destruction. Again, we even have habitat destruction. You can see here just creating a road to get and having the drilling equipment get to the tar sand pit, which is back here in this picture. We're digging through ground surfaces to reach those deposits, so we're actually destroying biodiversity. We're also using a lot of the nearby ground and surface water, so we're depleting that resource. Because like I said before, water's needed for the steam. Water's also needed for washing the bitumen. We have to get we just can't burn everything in the bitumen. So we have to wash out any of the impurities when we get to the refinery plant. And so, that's a real issue. And then there's a lot of water contamination. So, what's left over, the tailings that are left over from the mining process, have a lot of wastewater, or I'm sorry, it has a lot of contamination in it. Mercury, arsenic, we've talked about lead. And so, those things, if they overflow, can actually run into nearby surface waters where it can leach into groundwater. We even have things called benzene, which is a carcinogenic chemical that we find in tar sands that causes cancer. That's what carcinogenic means. We can have acids, hydrocarbons, like we said before, bitumen. All of these are toxic to plants and animals. And so that is a real problem. Okay. And then there's a lot of CO2 that's released by the machinery during extraction. There's a lot of CO2 that's released by machinery to transport the materials, the raw materials, and there's a lot of CO2 that's released at the refinement plants. So all of these things are problems. So more environmental consequences for just crude oil specifically. There's a possibility of spills from either the tanker ships or from pipelines breaking. Um, the spill can actually cover up the sunlight from reaching, the plants that are in the area. It can clog the oil, and if we spill the oil in water, it can clog fish gills. It suffocates many ocean animals for that reason. It can stick to bird feathers. We've probably seen pictures of, I know there's a video of the Dawn for Dawn dish soap where they use Dawn to cut down on the oil on bird feathers. They actually do that. It's a really sweet commercial. But we've probably seen that commercial. If there's a spill on land, it can be toxic to the plant roots, the surface water, the groundwater. It's all contaminated with those hydrocarbons. It creates habitat loss or fragmentation when land is cleared for roads or for drilling equipment or for pipelines. A lot of people don't like to live near pipelines. You can imagine, what if this was your driveway right here? That could be a problem. They're in remote areas generally. But if you live in a remote area and now you've got a pipeline blocking your view to this beautiful lake over here, that's not a good thing. And then fracking, what are some of the issues with fracking, or otherwise called hydraulic fracturing? Well, the vertical well is set up. And so you have to drill down to this area and, pump water and then collect the oil or the natural gas that you get from the area. And so a gun basically cracks that shale layers that are there around the well, and it makes it a more permeable surface so that we can then allow that gas to be released. We can collect that. The fracking fluid that we use is basically a combination of water, salt, a detergent, which actually breaks down the oil and releases the gas, and then acids. And that liquid is pumped into the well at the very high pressure to break that shale rock even more, so that the gas that's held within the shale is coming out of the rock itself. And then we collect that natural gas at the surface and we ship it off to be processed and purified at a refinery so we can then use it. And then what do we do with all that flowback water, all that liquid that comes back up with the gas? What do we do with it? And so it comes back out. We store it either in containers or we put it in these ponds that are nearby. But what happens if that infiltrates into the ground? It can get into groundwater, into rivers and streams. Okay, so that's a real problem. And here's the components exactly that we find in fracking fluid if you want to pause the video and you can kind of look at that in a little more detail. But as we can see, that is a real problem. And so, what are some environmental consequences with fracking? We can have wells leaking. We can contaminate the water with the fracking fluid, like we talked about. The ponds that we store this in can even overflow or leach into the ground. And this contaminates not just the surface, but also groundwater. It's toxic to plants and animals that rely on these sources. And then there's a depletion of ground or surface water nearby because we're using water, fresh water that we have for the fracking fluid. We also can get habitat loss that occurs and fragmentation that occurs. And then greenhouse gases like methane are released into the atmosphere, and also something called a VOC, which is a volatile organic compound, which we're going to talk about in Unit 7 more so than Unit 6 right now. But a VOC is just called a volatile organic compound, and that is a real problem for our air pollution. So, one other thing that's been mentioned in terms of fracking is seismic activity. And while it does increase seismic activity, they have been linked with wastewater injection wells. So what do we with that leftover wastewater from fracking? It's more commonly found with wastewater from gas and oil extraction. So the water that's left over from gas and oil extraction, because it's so toxic, has to be dug into a very deep well to be stored. So it's down beneath groundwater. And it has that all has high levels of mercury and arsenic and lead, things that we don't want to get into our water supply. So they dig very deep wells for that. And as you can see in Oklahoma, because that was a major issue, they were seeing more earthquakes than even California in Oklahoma. Oklahoma does a lot of tar sand extraction, natural gas extraction. Um, excuse me, they even have oil reserves there as well. And so you can see the number of quakes that they were having in Oklahoma. But again, these were from those really deep wells for gas and oil extraction and not necessarily the fracking wells. But people were associating it with fracking because when did fracking really ramp up? In Oklahoma, well, it's been used ever since the, I think, 50s in Oklahoma, fracking. But the well injections started occurring in the late 2000s. And so you can see here around 2014, the number of earthquakes they were having per year ramped up to the 500s. This is about the time they started doing those really deep well pump injections. And so that's more so what it was caused with, and not necessarily the fracking. But it is a risk associated with fracking. Okay, so our practice FRQ for 6.5, explain one environmental consequence of tar sand petroleum extraction and explain a different environmental consequence of hydraulic fracturing. And I think that's it for now. If you have any questions, make sure you talk to me in class. Our next topic will be nuclear energy.